And I would like to bring this document too, because I would like to refer this document. Let me know if you can see this
Hmm, I can
format
see.
document. Okay. Okay. Now let's say start.
Okay. You want to go
Uh,
back to that other screen?
Other screen. Okay. Let me reshare
Do you
it.
have your presentation?
Yes. Yes. I mean, it would toggle between screen. It is on my complete on screen too. Once I minimize this one, it would automatically
Okay, yeah. I see.
do that screen to share because I have two monitors, so it would automatically do that. So
Okay.
this is the one, but I just wanted to introduce with this document first because I couldn't bring in the entire document into the slides. Okay, where is this document? It becomes tricky. Okay. Hi everyone. Today we'll be talking about the time to event analysis data set. I would like to discuss more on this topic because of the nature of the data set and the importance of the data set. This is the most important efficacy data set that most of the clinical trials will be working on. And since it is so important, I would like to just uh, guide you to the functions that are available in the Admiral package, and also I would like to discuss in little detail more than the content of it, like actual content of programming purposes, but the variables, the required variables, and also the things that are required. I mean, that we do and why we do. I mean, like so more than actual variables, the importance of this data comes from the figures that we generate and the tables, supporting tables that are backing that figures. So that is the reason why this ADTTE is considered to be one of the most important data sets. I There will be more than what I'm going to discuss today because of time constraints and all there. There is some changes, like the ADTT has an intermediate data set and all that stuff, which we're not able to go over this today for sure. But I'll just give you the high level introduction of it and provide you links with that in whatever it is. Okay. So this is the main important document that I'll provide you the link, but the Adam title, final documentation, or if you Google it up by the Adam basic structure for time to event analysis uh, PDF, this that would bring you to this document, which is available online for download and would be updated periodically using the what you call the CDS people. So let's hopefully that they will be doing that or whatever it is. So it's up to them. Now let me go through my notes of it. And today that I would consider using Admiral package, a little bit of deploy R for the coding purposes, and getting the functions and all that stuff. So TTE analysis is usually is also known as suburb analysis. It's not only mostly important in the clinical research, but also economics and engineering and lot of other fields are actually using this TT analysis or survival analysis for the sake of concluding what their analysis is. So that's the reason why it is getting in prominence with the other studies. So, to in a nutshell, what is a time to analysis, TTD analysis? Time to event analysis actually focuses on duration from duration. It's until the specific event of interest occurs. So we'll go in detail about what is an interest, all that stuff. But the basic definition is duration. That this is the most important word that you want to keep in mind. Duration until a specific event of interest. So specific interest, event of interest is the main endpoint. and duration, how long it has been started from. So from to. So these are the two things that you want to put in. So unlike in a traditional statistical methods that might only consider whether event happened or not happened, the standard event analysis actually takes care of, how long, or, if something is happening or not happening, or why it is not. So we'll go through that too. So analysis accounts for time aspect and the possibility of censoring. So remember the word censoring. Censoring is the most important derivation or the variable or the column, whatever you want in the time to event analysis. Okay. The censoring occurs when the event has not been observed for all the subjects by the end of the study, or if the subject withdraws before the event occurs. So so the basic definition again is event did not happen. The event that we define, the event could be anything. We'll go through the events, all that stuff. Event or purpose of the study. Say, for example, the study defines the purpose, saying that it has treated, the subjects have been treated. So that is the main event. So treated of all the subjects by the study. And if the subject withdraws before the study or the event happens. So that you will consider that, considering that as happened or not happened, and or the let's say the result is either positive or a negative. There's a lot of combinations, or you can use as many words, but the censoring is either happened or not happened, and you assign a numerical value for it, meaning either it could be 0 or 1. We'll go through that, but so just for an example of what exactly a censoring is. So you need to understand these terms. So that this distinction makes the TTE analysis uniquely suited for data where the outcomes are not immediate or uniformly observed. Meaning that, say, for example, end of the study, say, for example, uh, you have a continuous, or like you watch a movie. I mean, like hypothetically, I'm just considering this example. You watch a movie where did you like the movie? Then movie is, if entire movie is good, yes, movie is good. The entire movie is bad, no, it's not done. But in it does not may not happen, right? The movie is like half of the movie is good, or half the movie is bad, or 1/4 or quarter of the movie. So it's a continuous event. Which part of the movie you didn't like it, which part of the movie you liked it. So it's all those things. Say if you want to consider those things in analysis, so you would say the TTE analysis. So this sensor variable, the second thing, the sensor variable, often denoted as CNSR, the way we show it in the uh, data set, is a critical component of time to analysis or survival analysis. It is a binary indicator that tells us whether the event of interest has observed or occurred for the subject with observation period if the subject was censored. Meaning, when I say a binary indicator, right? So you indicate with either 0 or 1 most of the times, but there are some studies or some people where they do a 0, 1, 2, 3, depending upon in this app again, or how the analysis want to be done. But most of the time, either 0 or 1 has per the city standards. Okay, so again, I'm concentrating more on censoring because it is the most important thing, right? So that's what most of why we do this ADTTE. So this you can read it through it. I provided little more information for the people who want to read. Censoring occurs when we do not observe the event of interest for the subject for the entire follow-up period. Okay, so this is what it is, and there are a couple of methods or in this censoring. It is right censoring, meaning that this is the most common type. It means that event of interest has not yet occurred for the subject by end of the study, or the subject was lost to follow up or withdrew from the study before the event happened. So these are the condition. I mean, these are the things, like when event happened after the study has ended, or like he has lost to follow up, or he left the study because of movement or whatever it is, withdrew from study. Look, how do we find out whether anything happened to them? So we know the subject was event free up to the last observation event. So we take it for granted that we know the subject was event free from the last observation period. So a patient has been monitored for, say, for example, this is an example that is being given for the IG. A patient has been monitored for disease progression. At the end of the study, their disease has not been progressed. We check through the EX data set and all that stuff, and their time is right censored. So we use the information from the disease progression, and then we conclude that this guy has been censored because a patient's disease progression has been stable. A patient moves away from the away and is lost to follow up. So what happens is that sometimes during the study, if the study is going on for, say, in example oncology studies, right, it goes to 10 years, 15 years. People move from within the city or within the country, and when the site wants to follow up with them, they did not follow up, but then whatever information we have, we do not want to lose it, right? So what we do is, until the last follow-up, they try to follow up, and if they could not follow up anymore, we use the last follow-up date and try to find out that it has been censored or not censored. Okay. So usually that comes under the right censoring category. There is also, there is also something called left censoring. This occurs when the event of interest has already happened before the start of the observation. So we know that event occurred, but not exactly when. So this is less common in clinical trials, as studies usually enroll the patients who are event-free at baseline. But this is more, more applied in other forms of industries. I did not have a choice. I mean, I wanted to check it out where the most left censoring is used, but I could not find the time today. But you can see this left censoring has also been applied. So, for example, in clinical study, the left censoring example is studying the time to diagnose a chronic disease, but some individuals might have been diagnosed before the study began. So the hypothetical is like, say, some of the cancer studies, right? Oncology studies. I keep on referring oncology because this censoring is, or this time to event is very prevalent in those oncology studies. So, a subject has already have a tumor, and he's been he's having that issue, and now he got enrolled into a new drug therapy. So in that case, we already know that he's been suffering with that tumor, or has got a diagnosis of the chronic disease. So that is already, so that's the reason why if we want to censor him, it would be a left censoring. Okay. And interval censoring is something, the example that I was talking about is somewhere in the middle. It happened, it happened in between, or it actually, it took time for him in between. So this happens when the exact time of the event is unknown. So instead of in the movie, you like the movie, but you really do not know where it happened, like it need not be starting of it or ending of it or in somewhere in, but yes, you liked it, or the event has happened. So, example, a patient is screened every 6 months for a tumor recurrence. A recurrence is found at the 12th month, but was not present at the 6-month visit. So the event occurred between 6 to 12 months. So we censored his day. I mean, 85. We got talk to ever, but within 6 to 12 months, he has been censored. So I think, hopefully I conveyed what a censoring is, and why, how, and what are the different types of it today. Any questions on censoring, or how it is or what it is? Hello?
No, not really. No.
Okay, good. So we have a basic understanding of censoring now. So how the censoring variable works, which indicates I was talking about earlier. The censoring variable is typically the 0 indicates the event of interest for the subject happened, and 1 indicates the subject was censored, meaning the event did occur. So sometimes the numerical codes, which was we were talking about right earlier, sometimes other numerical codes or character values used like 0, 1 standard. In some contexts, you might see a defined as 1 for event, 0 for censored. They do all kinds of different things. It's all up to the study people or study management people, but the CD, the document that I was referring to, or standard document, says that a time to event analysis follows 0 for an event, 1 for a censored convention. Okay, this is adaptability, or the you want to keep inconsistent with the Adam structure. You do not want to really change it to be consistent. You do not want to get feedback or comments from the FDA people asking why you did that or the, okay. It's up to, I mean, it's a small example that I would like to uh, consider it, but it's just simply explanatory, right? We have three, four subjects, and the date of analysis is basically 120 days. He had a progression zero. I missed the point where as per the analysis date, we were considering 150 days or 160 days, depending upon the trial analysis. So he had the APC01 had a disease progression 2023 at the date, on the date of 2023, 120 days after the treatment start. So I wanted to show the treatment start, but I did not as per the this thing, but showing them would have made more difference. So he has passed 120 days from the analysis from the starting of the treatment or the treatment start date. So his sensor analysis is 0. So he has reached the progression free analysis, or his tumor was progression free. So 002 we was censored at 180 days after the treatment start date. This means that at this date the disease had not progressed. So his tumor did not progress anything. The sensor is 1. They might have completed the study without the progression or been lost to follow-up. So this guy has been indicated 1 because the other reasons. So completed the study without a progression, or so there could be that. The next thing is has progression 0 because after the treatment again, and these are all examples basically coming from the Adam IG guide. Like they are trying to give the examples how we can use it for our our data analysis. So was censored after two eval days. The total number of days is 210 because this treatment date, I mean, difference between the ADT, the analysis, actually the flag happened, and the treatment start date. Treatment start date is 1. The sensor variable is fundamental for the properly analyzed time to event, ensuring that all available information is used. So here we have there's a 210 days, total number of days is being used for the complete analysis. Okay, so we need to have an ADT. The analysis date happened. We will see how this analysis date has to be calculated, and the difference between the analysis date or the EDT from the treatment start date will give you the eval, the total number of days, and then check whether it is censored or not censored. Okay, so that is the kind of print that you need to derive within the analysis data set or the ADTTE. So again, the importance of analysis data set, we'll see that, but why we use it, or why we need to have it. Then the ADTTE is basically extends the Adam basic structure as per the like we were talking about it, right? This ADTTE comes under the class of BDS structure, meaning that we'll be having, all of them top to bottom, the top to bottom, and more than one variable. So we'll be seeing the structure of it later on, but with additional variables, specific time is defined. The naming convention is same as other Adam structure. The Adam BDS is flexible and can handle various outcomes of TT analysis. It's generally recommended to store time to events separately from non-time to event data structure, even though if both of them fit together. Right now, today we are not, we are not covering the non-time to event data sets. So just only the time to event that we'll be concentrating. And there are sometimes sponsored sites. Basically, most of the time, it's the ADTT data sets needed for the study, prioritizing meaning that if they have more than one category or one param CD or one of them they want to see, we'll just club various params or variant param CDs or variant in the time to event analysis. So it would be more than one record per subject, but for different parameters. So this information, you need to keep that in mind. That is the reason why it is a BDS structure. So this information is helpful. The common and the most important part of the ADTT is that it is used for efficacy analysis or efficacy data sets, efficacy tables or listings. So that's the reason why it is used for the statistical methods. So we'll see the different statistical methods that are used, or one example at least. Because most of the time, this structure has to support the KM curve or the Kaplan-Meier product and the log rank, Wilcoxon test, the Cox proximity test. These are the prominent tests, or the tests that are using the ADTT datasets to provide the related information. So that's the reason why, to support the analysis or needed, analysis needed for say proc GM or procedures. Sorry, my bad. I am going back to my SAS world, but the Kaplan-Meier KM product, or where we need. So we keep that structured in such a way that we can use the directly the procedures, these procedures from the data frame, or that's the reason why it is all the variables are needed in that way. So it's basically the capabilities, whatever it is, you can just read through it and add a metadata structure. Now we'll come back to the ADTT metadata structure. Now it's an ADTT data set. That's the name of the data set that it is there. And the description is time to event analysis. As it is said, time to event, right? So it's all related to times, what is the randomization date, or, what kind of starting date we are using, and end date, what the end date for analysis. So we just want to compare them. So it's all time. So if that variable or date of death, so for example, death is a primary analysis that we're looking. So date of death is missing. We need to make sure that we are using a different or the date where we can consider that as a date of death. So there are a lot of things as for the SAP we need to consider to make sure that dates, whatever dates we are using for the ADTTE, are not missing. We cannot have those. So that is a basic level of understanding that I have. Maybe I'm not. I could be wrong because of my inexperience. But most of the time, what I see is that the dates are not missing, and the data structure is one record per subject per parameter. This is the most important thing. Like you can say one record per subject, but it can be having more than one parameter. That's the reason why the subject counts do repeat. So use subject ID and param CD are the most important things that we consider for sorting it out for the key variables. When you open the ADTT data set, so that ADTT.SAS, I don't know, like they just kept it out there, so I just put it out there. but it's up to, we are in a different language platform, so it could be different. Any questions till now?
No, not really.
Yeah, I know it is too technical, but bear with me that the concepts are more important than the programming part here. That's the reason why I'm going back and forth and spending more time on the concepts of here, this data set. So once,
Yeah, the one record per subject ID per parameter is very important indeed. Yeah.
yes, one record per subject per parameter. That's the most important or heart of the ADTTE data set.
Any
Yeah,
chance that you used to use this data set to create an reverse cumulative curve?
we'll go through that. I mean, at least
Oh,
from
okay.
my understanding, we will go through that examples later on. But because of the nature of the graphs or the tables that we are trying to produce out, we are trying to use the ADTT data set. I mean,
Yes. Yeah.
if it's not fit into our this thing, there is an intermediate data set, one before this one, where I have seen some statisticians requesting for that to get an intermediate data set as per the modeling, where the visits are
Yep.
missing or where we need to do it. I have seen that situation too, where you do some kind of what you call, kind of filling in the gaps. I would say that filling in the gaps when there are missing visits or missing terms. So I mean, like, I did not prepare my slides on that, but yes, we use ADTT for most of the common statistical procedures that are requested or that are required for checking out how a drug or something is doing at the time of, I mean, the event, whatever event we are describing. Okay.
Okay.
So, yeah, I did not actually play with the words, but I'm trying to say this part. That's my understanding. Okay, so the time to event analysis, as per the IG, we do have the core columns, expected, required, and conditional and permissible. So these are the similar things that we have for other BDS structure variables. Okay, so we'll be going. I mean, I'll be concentrating mostly on core columns for today's presentation. Okay, or the required data set, required variables. My bad. The variables that are necessary for the DTT and the required variables. That section basically what is required. The section required Adam structure is the variables that are read is required for a given data set for the rows to be meaningful. Okay, so though these are the ones which makes the data set, the ADTT data sets, most relevant, or it explains something. Others could be supporting artists or supporting people, for the other variables which are already there to be more descriptive or more meaningful. But the requireds are the ones which are required. If at all we are submitting that this data set to the FDA, the required variables cannot be missing or cannot be empty. So that's what the rules, the IG rule says. Okay. The list of required variables are subject ID, use subject ID, sorry, use subject ID like any other Adam data sets. Eval will define the define of eval here is duration of follow up. Either it could be days, weeks, or months, depending upon how it has been defined. Okay, the eval definition is in the ADTT is the difference between the duration, or I would say duration or the time between these two times, starting from the treatment to the end of the day where the sensor event happened. The sensor variable, what the definition of sensor is, a binary indicator of event occurrence. Either event has occurred or event has been censored. Okay. The ADT, the analysis data variable, is a date of event of censoring. So we use this today. I mean, the date of event actually happened. that we are going to capture that date, okay? And that's going to be in ADT. And param-cd is a short code for what is that event, what is that event happened? Is it is a progression fee or occurrence fee, what exact acceptance. So that overall survival or the progression fee, or what is that event happened, what is that, because if the table indicates that we want a table for progression fee analysis, we'll be subsetting or using the param-cd data variable and subset it to the progression free analysis, and then find out how the sensor variable or the time to event happened. If it is we are looking at an overall survival table, then we'll be using the param-cd overall survival and do that. So that's the reason why this is the other variable that is most needed. And param is basically the supporting for param-cd, and they go hand in hand, depending upon how you want to do that. So that's exactly the thing. Okay, so you can go through this one, how the Admiral package will go through right now. I skipped that because it's just a concept for my understanding. But the Admiral concept is basically that the Admiral package does support the creation of ADTTE dataset, and we have more information at this location. The ADTTE HTML, this thing, where I'll go through smaller pieces of it, with most important part of it, which I feel. So we bring in the information from various sources. The most important then are from the ADSL, where what kind of information, whether the safety or the intent to treat population, or what kind of population we are trying to do it. And then we just merge it back with the ADT base or whatever the data set that we are using it. I mean, we have a lot of detailed information in that, the article or, that location. But the most important parts are you have one data, the information about the treatment start date and the dosing information and all those things. You need to recognize them first and then try to bring it out back into the one data set. So that's the most important concept here that you have to keep in mind. So once you bring in, then the next most important part of is the ADT, generating of analysis data set. Analysis data ADT represents the date of the event or the date of censoring. It's crucial because it's anchoring the eval. Basically the eval variable, which is the most important variable, or the whatever variable. I mean, one of the required variables, right? Eval uses ADT. So that's the reason why we need to know the ADT or the date of event. ADT is based on the event occurrence or censoring logic. So we need to, it is not a straightforward date. So we need to look at the CSR, or how it has been defined, and we need to figure out derive the ADT event based on, and picks up the first non-missing date. Okay, so this is also a logic. Basically, the first non-missing date has to be picked up. So how we are going to do it is picks up the non-missing date from the program date or whatever the dosing date, the first dosing date, and the death date. These are all the things you need to check. Or these three dates, last available date, check all these things and pick up the first non-missing date. Okay, this is the programming logic that you need to keep in mind, how we are doing it. So once we have this date, once we have the date, and then we use this derived variables function. Derive as date is already available in Admiral package. That is the functionality that we are going to use. Sorry, that is a function that we are going to use, and feed in the ADT temp. The ADT temp is the one, and you derive this DTTC variable. Okay, and this is, once you have this one, this knowledge is, or this understanding of, how we can create the first non-missing date, getting the date is not that hard. Just pick up the one and all that stuff. And there is basically a dedicated function within the Admiral package to derive all information needed for the TTE data set, and that is something called derive param TTE. Okay, so that the underscore TTE indicates that it is from the ADTTE data set, and the remaining all is Admiral standard way of saying that it is a derived variable or it is deriving the parameter. So now it has other options like what is the data set that we are merging in, the start date. Here in this case we are using the start date as a randomization date, the date of randomization, and event conditions is a death event or a PD event. List of them, we can list it out like that. And the death event is like whether the death has happened or the death date. Whenever there is a death date, we'll be listing that. And then how would the sensor conditions, is there a left sensor or random sensor? I mean, like we can check it out. You can check it out the remaining censoring conditions, but you can explicitly say it is a left censoring or a right censoring or interval censoring. You can let the functionality know about it. And the source data sets this is the most important thing, where we need to list out what are the information that we are taking it, either it is taken from ADSL, the randomization date, or what date it is, and also from the ADRS dataset. The ADRS dataset is one step before, or like some people will store their information in some other different data sets, or we need to let the function derive underscore param TTE to derive what information or from which data set we are taking out. In the situation or in the example that is being shown here, we are looking for progression-free analysis. So that's the reason why it is the progression-free analysis is calculated in ADRS. So the ADRS has to be available for us first, along with ADSL, and we can use this ADTTE or the derived param TTE. Okay, so we cannot have the if these two data sets are missing, this function we cannot use this function. So that's most of the time the ADTTE comes at the last of the analysis data sets, most of the time. But just in case, sometimes in the last study that I worked, they wanted ADTTE censoring done for one of the ADAE components. We had to derive that, the components, everything within the data set, within the entire thing. So depending upon the study or depending upon the requirement, this can changes. But if you have everything, ADRS is available, ADSL is available, you can use the derive underscore param TTE for sake of generating it. Okay. So hopefully, I don't know like how to make it bigger, because this is cutting it off. But anyway, I just wanted to show you is the eval information, where the eval information is, see here, the derive underscore param TTE. This is also, like the Admiral function, where you have entered all the information needed for the eval, the eval time. So treatment start date, programs event start date, and sensor start date, the sensor reason, the param code, eval. So the new var is eval. This is the you can this is thing that calculating the time duration, start date and end date. This often is in days, months, or so. Admiral package has another condition where you can say it as a weeks or days. Most of the time it is weeks. For I mean, at least in some of the studies that I'm working on, is weeks. But there are certain studies where they were looking for days. And also year. You can actually define year, something. So all those things, this is often months too, right? Weeks, days, weeks, months, provides missing partial dates. These are all have to be cleared. Like that takes care of a lot of these things. So before you calculate these things, make sure they are not partial dates and all that stuff. That's the reason why the beauty of this Admiral derive underscore param TT is so beautiful that it takes care of, if the dates are partial, it takes care of them, converting them into the complete dates and giving you the new variable eval value, because we do not want to lose any kind of information we've been collecting, right? But make sure you do all that, all these partial dates and everything beforehand, for the sake of understanding or the for sake of consistency. We the rules might be different for every study. So if there is a missing date, say for example, the death date is missing, then there are certain places where you go and look for the death date sometimes, and that changes from study to study to study. So that's not always a hard and fast rule where you can consider the death date as so and so, or missing dates are always a missing. So just make sure that that's the main thing for the programmer, that has to keep in mind how to calculate the death date or the missing dates. If there's a missing dates, how can we use other dates for the sake of generating the value, the eval value. Okay, so that's the most the crucial part of programming the analysis data set. Any questions till now?
No, not really. But then for ADT, it's better to already use another step to impute the date.
Yes.
Yes. Okay.
Yeah, we do that. Yes, we do a lot of imputations before getting the ADTTE, or the ADTTE data itself would have the imputations that needs use other avenues, because we do not want a missing value for the start date or a missing value for program date or the date of actual event or the death, depending upon, because that is the most crucial, right? I mean, the sensor value uses the eval, and eval, it goes back. So the dates, the missing dates could be the most problem for the ADTT. That's the reason why you need to check all the evidence, all the available evidence. And we need to find out with the statistician if there is missing. The statistician has to step in to tell us what date to use. Am I clear on that?
Yes.
So any other questions, Priyanka? Okay, so once we have that information, so we'll just using the what you call the sensor function, which is already been derived here. The same thing, the derived parameter, derived param underscore TTE also, calculates the sensor variable. Okay, I just made it sure that because it's in the very end, there is eval is calculated. At the same time, you also can derive the sensor variable. Okay, so it looks here, the sensor variable, the name of this, either it is and the most important thing using the Admiral package is that it uses 0 and 1 as per the CD standards. It does, you cannot change. If you want to change, then you have to do a little bit of crossing outside the derive underscore param TTE, but the derive underscore param TTE uses the CD standards. That's the reason why we are using it, but it's just FYI for the people who want to do it differently. The sensor indicates whether the event has occurred 0 or was censored 1. So keep that in mind. Event occurred is always 0, was censored is 1. So its derivation is inherently linked to ADT and eval derivation, which we took a look before slides. Okay, So the Admiral package automatically does the censoring, like we discussed based on it, and sensor date. So we can whether the event date is missing or present related to sensor date or sensor date. So it uses the event date and the sensor date, right? That's the reason why the it has to be not missing so that this sensor variable can be collected. I mean that's the importance of not having any missing dates. So that's the thing. And the parameter, this thing is quite relatively straightforward. So the derivation is specific to TTE ending. And the Admiral concept, the derive underscore TTE would also have the parent code, parent CD, parent discretion, and everything would be also been included in the same derive underscore parent TTE. And we can create those things. Okay. Now I just have a summary of it. Why the Admiral package is little bit different and very effective about creating the ADTTE, because this derive underscore param TTE function looks into a lot of things, like even though it is just providing, we are just providing the two data sets, related data sets, and the variable. If there is any what you call any missing dates or any missing say partial dates. Sorry, for example, there's a partial dates. It actually converts them and make sure that they have complete dates. And these derive underscore parent TT would call other related information or other related functions behind the screen, so that we can convert all of them into partial dates. Complete dates, so that the ADTTE data set comes right at me. So if you are doing, or if you're using any repair package or any other package, you need to make sure that those dates are not missing and in the right format. They calculate the duration, and then and then have those dates ready. I mean, in a certain format where you can find out the sensor variable for that. So all those things are done by using the derive underscore parent TTE, and that makes the Admiral package easy and most beautiful to use rather than the deploy. So that's the most information that you want from the creation of ADTTE. I mean, like that's 90% of work done. But if you understand why and what it is used for, then you will understand why it is so important. Okay, so the KM curve will be going through one example because I don't think so we will have time for that. But okay, the KM curve usually looks like this. Okay, the step curve, there are a lot of names, but the Kepler-Meyer plot is one of the most important things that we generate in this one. And we generate it, but we just need to know how and what it shows to just make sure that we understand the graph, right? So what it shows is usually represents a probability of patients remaining PFS, the progression free over a period of time since the starting of it. Compares the probability of two groups, drug A and drug B. So if we go back, there's a two curves, right? The treatment A and treatment B. Okay, so it does that. I really don't want again back and forth, but you can take the look. The x-axis represents the time in months. We were talking about it earlier, right? Where we can have it under months or days, or depending upon what kind of duration you want. Most of the time months. It shows how much time has passed since the start of the observation period. Example, the start of the treatment or the randomization. So total number of days from the drug taken to the event happened. The total number of, and usually if that month, if it is months, right, it is easy to read and see the for longer most of the values in the graph. the time in months. So y-axis is represents the estimated probability that a patient is still progression free. Okay. So this is an estimation, and this is the probability indication, right? This is what it is trying to show is progression-free survival, and we are if we are looking at the PFS table. Okay, PFS table is estimated probability that a patient is still progression-free, and I'll tell you how the statisticians read and all that stuff, but it ranges from one because the probability could be either zero or one, right? So it is in between those ranges. One is the probability of being even free, and zero probability. So that's the reason why it is only zero. Like make sure that your axis and all that stuff. It's a percentage. But we'll read through that again. We'll come back. But the y-axis is something one to prove why it is a probability. We'll just discuss that. Do not get confused. So the curves or the drug array versus the placebo, that's step curves, right? Each curve, if you have multiple treatment arms, you will see you'll see all this multiple treatments. Like, so this is indicating a treatment A, this is using the placebo, or treatment B. Depending upon you will see a lot of either you start with here and it goes down, depending upon the number of weeks, it is going down, or flat to the x-axis. You'll see a lot of that, but that is where you need to understand that there are treatment arms, those steps, okay? Steps on drop curves indicate that an event, disease progression or death occurred one or more patients at that specific event. The size of the drop indicates the number of related patients. Okay, this is other interesting that you need. Underneath is number of months or events, right? The days of randomization. And the longer this thing is, that nothing has happened. The subject did not have the progression or nothing. Just he has got stable. He took a drug here or here. If it is flat, if something happened flat for a certain amount of time, so he was stable, kind of stable. So that is how you read that. Any questions on reading the graph?
No, not for now.
I'm not sure if I made a good job in reading it, because reading the graph is the most important part of how or if the data is right or wrong. So that's the reason why I'm going back and forth with that. So once you have, so the supporting the tick marks and those things are also there. But I have everything in my notes. You can actually go back and see that. Okay, this is the table, supporting table for that graph, where we calculate the median time, event rate, and number of sensor. And the information from this table has to match the graph that is being generated. Okay, and it compares the median time, basically compares the treatment A versus treatment B, and the confidence intervals tell you how long it is good, and the p-value, if it is less than 0.05, it indicates that the treatment A is better than the treatment B, and statistically significant. So these are all the information that is conveyed using the table or the graph. It's a lot of information is conveyed using the Kaplan-Meier graphs, and that's the reason why this is the most important tables. Basically this table, time to event Cox regression table, also indicates that this is the survival as a p-value. If it is less than 65, it's greater than 65, it will tell you that number of subjects or number of people who are greater than or equal to 65 have less chances of surviving to the people who are less than 65 using this drug, or that actually the ranges. It will tell you, this will tell you a whole lot of information, whole lot of indicators from these three tables. So that's the reason why the ADTTE is more needed or more significant data set that in the entire study. I know that we Any questions till now?
No, funny.
Okay, so this the I mean I'm going to push it. I need help with pushing it, but we can call it as an and, because I do not have anything more to show. I mean, these are all my conclusions, like how to improve all that stuff, but people can go over it. Not sure whether it's not written in the book, but like it's better to have the understanding of these things while creating the Adam data set or the ADTTE. Otherwise, it's just using the functionalities of Shun does not make any sense. So that's the reason why I just kept it here. But I'm going to push it to all the slides will be available for the other study program. We can call it as an and.
Yeah.